Okay, this is going to be part 6. I'll probably do problems 11 and 12 on this video. So same instructions as before. Hopefully we're getting the hang of this. I suspect this derivative is going to be a little bit nasty. And for the same reason I suspect that, it reminds me I should probably think about the domain of this function. So let's think about that. I know I cannot take the square root of a negative number. And clearly if x is big enough, we're going to get 8 minus a large number, and we'll be well into the negatives. So what I really want to know is, when is 8 minus x squared equal to 0? And that would be at x squared equals 8, or x equals positive and negative the square root of 8, which is simplified to positive and negative 2 square root of 2. So really what we need to do, and I hope this doesn't confuse anybody, but I really kind of need to think about a sign chart of my function, because I want to know when it's, well, not so much the whole function, but just the inside of the square root. When is this positive? When is this negative? I just found out where it's 0 at 2 root 2 and negative 2 root 2. So if I pick a number like 0, which is in between those, I get a positive number for 8 minus x squared. If I plug in a number like 5 or 10, anything bigger than 2 root 2, and I see that I get a negative. And the same thing happens if I plug in a number out here. So what this tells me is the only values that will work within the square root, and therefore the function, would be the ones between negative root 2 and positive 2 root 2. So that's going to be my domain. And the endpoints are fine, so I need to include those. Alright, now I think we're in for some fun. So let's take the derivative. I suspect I'm going to need all the room I can get. Product rule. Derivative of x is 1 times the second function plus x times the derivative of the second function, which would be 1/2 8 minus x squared to the negative 1/2 times negative 2x. Let's clean this up. I get the square root of 8 minus x squared plus, actually let's go negative on that. We have a negative 2 times an x. Actually the half and the 2 will cancel. So it looks like I get minus x squared. The half, the 2, I took care of the x's, and then all of this would be in the denominator as a square root. I want to simplify it. I like my derivatives to be single fractions. So I need a common denominator, which means, looks like this fraction needs me to multiply by the square root of 8 minus x squared on the top and on the bottom, which really would just mean I need another one up here, which would end up squaring that. So for shorthand, I'll just do that. So the square root cancels out, leaving me with 8 minus x squared over the square root of 8 minus x squared, leaving me with, I think, what we will leave as 8 minus 2x squared over the square root of 8 minus x squared. Alright, so there's my derivative. And, as sad as I am to say it, it looks like we now need to find my second derivative. So, we're going to take the derivative of this quotient rule. Derivative of the top is going to be negative 4x times the bottom minus the top times the derivative of the bottom, which will be 1/2 8 minus x squared to the negative 1/2 times negative 2x all over the bottom squared, which would just be 8 minus x squared. All right, let's simplify. First thing I notice, I've got two terms on top, but one of them has a negative exponent. So that negative exponent needs to go to the denominator. But if I just drop it down and join him with my friend here, that's going to give the implication that when I bring him down, he's actually going to divide this. And he's not. So I think really to continue, I need to separate this. And pretty sure I'm going to run out of room with this problem. And time, for that matter. So let's see if I can write a little smaller. Alright, I have a negative and a negative, which makes a plus. I have a 1/2 and a 2. I have an x times all that stuff. So let's go ahead and distribute that x in here, giving me 8x minus 2x cubed. And then I have this square root, which is going to go to the bottom. But I already have this in the bottom. And so he's going to join him. Okay, now I need to turn this into a fraction again. So once again, it looks like my common denominator is simply going to be, they both have the 8 minus x squared. This guy needs the square root, both top and then multiplied on the bottom. And the easiest notation would be, let's just square that since it's the same thing. Okay, so let's see what we have now. On top, the square and the square root cancel out, leaving me with negative 4x times 8 minus x squared plus 8x minus 2x cubed all over 8 minus x squared times the square root of 8 minus x squared. Alright, a lot of this is going to get erased. Let's squeeze one more line in here. Distribute the negative 4x, negative 32x plus 4x cubed plus 8x minus 2x cubed over 8 minus x squared over 8 minus, or under the square root. Alright, simplifying one more time, let's move over here. It looks like I got a 4x cubed minus a 2x cubed. So I get 2x cubed. And then I have minus 24x over, and if I wanted to, I really could actually combine the denominator together, because since they have the same base, I really have 8 minus x squared. This guy's to the first power, this guy's to the 1/2 power. The rule says if you have the same base, we can add the exponents. So 2 halves and 1/2 makes 3 halves. And this is as good as I'm going to get the second derivative. Okay, I need some room to work, so I'm going to erase all of this hard work. Hopefully this video doesn't crash on me. I don't want to redo it. Alright. So now it's time for my first and second derivative test. I think the hardest work is behind us. Okay. So let's change colors. You probably heard my daughter in the background there screaming. She's having fun running up and down the hallways. First derivative test. Alright, so here's my first derivative. I want to know when the derivative equals 0, and that's only going to happen when the numerator equals 0. Which looks like we're heading for x equals positive and negative 2. That's really messy. Sorry about that. Not going to fix it. But I also better consider where the derivative equals 0. I'm sorry, undefined. I am going to fix that. Alright, so my derivative is going to be undefined whenever I divide by 0 and whenever the square root is negative. Well, you'll notice that the work we did with the domain up here at the beginning, it's the same square root function. So the same values that didn't work before aren't going to work again, which is great because we weren't going to consider those points anyway. However, you'll notice the inclusion now. We said we could use negative root 2 and positive 2 root 2, but if I were to include those in my denominator here, that would cause 0 in the bottom and therefore be undefined. So it looks like I have some critical values of x equals positive and negative 2 root 2, which also happen to be my endpoints. And I think that's going to be a pretty common theme when you have this kind of a function. Okay. Wow, we're at 12 minutes already. So we're going to make a sign chart. And this sign chart is going to be pretty much bookended by these 2 root 2 numbers, because you'll recall that the domain is only in between them. So we're not even going to think about plugging numbers in out here. We have negative 2. We have positive 2. Okay, so using my derivative, plugging in 0, which is in between. Top, I get a positive. On the bottom, I get a positive. Between 2 and 2 root 2 is going to be, I don't know, let's pick a number slightly bigger than 2, like 2.01. And then we know that the numerator now is going to be 2.01 squared, which is a little bigger than 4, times 2, which means a little bigger than 8. So 8 minus that would be slightly negative. The bottom is going to be positive. So I get a negative. And then go the other direction, plug in a little bit of negative 2.01 or something, and it's squared, so I'm going to get the exact same results. So I have some of my answers. Let's go write them down. When is the function increasing is what A is asking. I think we should all be in agreement that that's going to be between negative 2 and positive 2. When is it decreasing? Negative 2 root 2 to negative 2. Union 2 to 2 root 2. C is concave up and concave down. We're not ready for that yet. Part E is local mins and maxes. So, thinking local minimum, we have negative 2. We're going down and then up. Local max, we would have positive 2. But we actually have 2 more, and that would be the endpoints. Notice that wherever my endpoint is at negative 2 root 2, what happens right after it? My slopes are negative. So again, looking at a rough graph of it, I don't know where that is. We'll just pick a y value. But right after that y value, my slopes are negative. So I'm going down from that point, making negative 2 root 2 another local max. And then as we approach the other endpoint, wherever it is, we have a negative slope before I get there. So let's say I'm at this point right here. The negative slope tells me I'm going down to it, which makes that a local minimum. Alright, so we're going to need y values to go with all of those, and again, by now we should have this down. We'll get those y values by plugging them into the original function. And we should already be able to tell that those two values are going to be 0. And then I'll let you find the other two. Okay, let's do concavity. So now we're doing the second derivative test. So we set the second derivative equal to 0, and we set the second derivative equal to undefined. So the numerator is all I care about for 0. And I can factor out a 2x, leaving me with x squared minus 12, leaving me x equals 0, and leaving me x equals positive and negative the square root of 12. I think that's correct. Which is actually positive negative 2 root 3. 4 times 3 is 12. And you'll notice that 2 root 3 is actually larger and therefore outside of my domain. So I'm going to just throw those away. I need to look at when the derivative is undefined. And once again, that's only going to be when the denominator equals 0 or when I'm taking the square root of a negative, in which cases I've already dealt with both of those. So that's not going to add anything new, but when I do my sign chart for my second derivative, I need to include those endpoints anyway, just like before. So whether you thought about it or not, you're going to find those same 2 points, and therefore we'll get them on my sign chart regardless. And then the only other value is 0, because once again the positive and negative root 12 are on the outside. Okay, we are almost done. So now I'm going to pick a number between 0 and this, like 1. And on the top, I get what appears to be a negative. The bottom would be a positive. And then on top, if I plug in like -1, that's going to end up giving me a positive value. And so I am pretty much done. Concave up. This is in the way. Concave up from -2 root 2 to 0. Concave down from 0 to 2 root 2. And I think F is actually supposed to be inflection points, which is clearly going to be 0, comma, plug that back in. Let's recenter this. Plug that back into my original line, get 0, comma 0. So that's my inflection point. So just to test ourselves, what is this graph going to look like? I know that at -2 root 2, I have 0. At positive 2 root 2, I have 0. And at 0, I have 0. I have a local minimum at -2 something. I'm just going to guess at the point. I have a local maximum at 2. I'm going to guess at the point. I'm concave, and the rest of this I'm going to figure out with concavity. I'm not really even going to look at increasing, decreasing, because clearly it's got to be increasing to get from this point to that point. So I am concave up, so bowl-shaped up to here, and then from 0 to 2 root 2. So this is an inflection point here. Now I'm going to concave down until the end. Okay, hope that helps. Watch the video a couple times if you need to, and we'll pick up number 12 in the next part.